Hello everyone, welcome to the lecture on discrete Fourier transform. This is Sai Kumar studying 3rd BTech. Today in this lecture we are going to discuss about divide and conquer approach to compute DFT. So while let's get into the lecture. Let us look into the equation of DFT where small x of n represent input discrete signal and capital X of k represent DFT of small x of n. And x of k is given by summation over n equal to 0 to capital N minus 1 x of n into omega n power kn. In order to get the original series from x of k, we are going to apply inverse discrete Fourier transform by using this equation so that we will get the original signal. And nth root of unity is given by omega n and omega n power n equal to 1. Now let us question ourselves that why are we going for FFT algorithm even though we have matrix method or direct method to solve DFT? The answer is very simple. In order to reduce the cost and also the direct computation of the above equation requires numerous number of multiplication and addition. In order to reduce number of additions and multiplication, we follow some algorithm. Divide and conquer is one such type of algorithm. Before we move to the algorithm, let's recall symmetric and periodic property, which are basic for computation in divide and conquer approach. If you guys want to have a clear idea about the properties, please go through the links mentioned in the description. Now, symmetric property is given by omega n power k plus n by 2 equal to minus omega n power k, and periodic property is given by omega n power k plus n equal to omega n power k. So these two properties led to the divide and conquer approach. So let us go through the brief idea of algorithm for better understanding of upcoming lecture. So algorithm is as follows: storing the signal row wise, computing the L point DFT, then multiplying the resulting array by Bayes factor, then computing M point DFT, then collecting the resulting array column wise. So this is how the algorithm works. Now let us consider a signal has n number of samples. We are going to write n as a product of two numbers, that is n equal to L into m, where 0 less than L less than capital L minus 1 and 0 less than m less than capital M minus 1. By this way, we can able to store the elements in two dimensionally. It may be in the form of row wise or column wise. So in this video, we are going to represent using row wise representation. Now, so the representation is as follows. See, suppose we select the row wise mapping, that is n equal to capital M small l plus m. So if you observe the figure carefully, there are first m elements in the first row, second m elements in the second row, and so on last m elements in the last row. As this is starting from 0, so total there are L rows and m columns. So L into m, total number of elements are n. So which is equal to input signal. So now similar representation can be used to arrange the computer DFT values in also, that is x of k. So x of k can also be represented as a p comma q using two-dimensional array. So where p ranges from 0 to L minus 1, q ranges from 0 to n minus 1. The mapping can be either row wise or column wise based on how you are going to take the input mapping. For example, if you take input mapping as column wise, then you have to take this as row wise. And if you take input as row wise, then you have to take this x of k as column wise. So that is in this video, as we are following row wise operation, that is n equal to ml plus m and k equal to ql plus p. So coming to the equation, the DFT can be expressed as a double sum over elements. That is, now x of k is represented as p comma q and n is represented as l comma m. So we have the summation symbols here, omega n power kn, and k value is nothing but capital ML plus m and n value is nothing but QL plus m. Now just consider this equation for better understanding. If we multiply ML plus m into QL plus p, we are going to get this equation. If you want to calculate, please pause the video for one time and calculate it so that you will have a better idea about what we are going to discuss. So after calculating, we are going to get the omega n power something like this as like this. So we already know ml is nothing but n and n equal to ml. So this is the equation we are going to get as mentioned above. So we already know n equal to ml and m equal to n by l and l equal to n by m, and omega n is nothing but e power minus j 2 pi by n. So therefore, omega n power ml ql can be represented as ml is represented as n and n and both are cancelled. We are going to get e power minus j2 pi, that is equal to 1. Now omega n power mpl we will get like this, and omega n power l per lnq we are going to like this. After substituting all these values in the equation 1, we are going to get the equation as follows. On rearranging these terms, we are going to get the equation is follows. First, we are going to compute the equation which is inside the bracket, then multiplying it with the omega n power mp, which in this case we are going to call it as a Tidal factor. Then the whole up, I think we will see. See, now what we are doing, we are going to calculate which is inside the bracket. That is, I am representing that with the help of f of m comma q. So after computing this, we are going to multiply it with T-dual factor. So this is the T-dual factor we are going to represent. So the whole value is I am representing as g of m comma p. So g of m comma p is nothing but f of m comma p into T-dual factor. So this whole thing is now represented here. So this whole thing is now represented here. We remove this thing, and in this place of this thing we are going to write as g of m comma q. The resulting equation is this: x of p comma q is so summation over m equal to 0 to capital M minus 1 g of m comma p into omega m power pl. So if you observe it carefully, it is nothing but m point dft. So if we compute m point dft using this equation, we are going to get another array, that is like two-dimensional array. If we collect it column wise, then it is nothing but DFT of the given input signal. So this is how we are going to use the divide and conquer approach row wise. Thank you.